Friends, welcome to Chemolution, enriching minds many at a time. Today's topic is calorimetry and its relevance in terms of process safety. So what does calorimetry means? It is basically the science of measuring heat exchange between a system and its surrounding. As you can see in the image, you can see a cup. It is made up of styrofoam, which is a non-conductive material. It does not allow heat transfer. There is a liquid filled in the cup and there is a thermometer. So this is basically a uh, instrument or a set of instrument used for calculation of heat generated in a reaction in an open system. So if you have a exothermic reaction inside this cup, the temperature in the thermometer will rise, and we can calculate the heat liberated by using the equation Q is equal to mCp delta T. M will be the mass of the liquids that are present in the system. Cp will be the specific heat of the mixture, and delta T will be measured in the thermometer. This is not a very highly efficient or highly reliable system as there is loss of heat to the surrounding, but this can be considered as a fundamental for other calorimetric instruments that have developed over a period of time. So why calorimetry is important? We must know what and how much heat is being liberated in a process so as to manage that heat by source of cooling, and what will be the impact of that heat on the materials. This is another type of calorimeter known as bomb calorimeter. This is basically a constant volume calorimeter because the volume inside this calorimeter is fixed. This setup, if you can see, there is a steel bomb in which a sample is kept, and there is an ignition coil inserted from the top. Now this coil is used to ignite the sample, and this coil is used to ignite the sample, and when it is burned, the heat generated by it will be taken up by the water which is in the surrounding region. To help the heat transfer, there is a stirrer which increases the overall heat transfer coefficient, and whatever heat is liberated by this material, it is being transferred to this water. The water rises in temperature, and the rise in temperature is measured by a thermometer. So in this case, once this material is ignited, it will burn and give its energy out to the water. This water, which will be heated to certain temperature, then will give a delta T, and we will use the similar equation that we used in case of styrofoam calorimeter to calculate the calorific value of this particular material. Bomb calorimeter is used to find out calorific value generally of fuels like coal so that they can be used in the proportion of the heat that they can generate. This is a calorimeter which is used for assessing the calorific value and not for the thermal stability. Now we will move on to the differential calorimetry. Till the time, what we have understood are the calorimeters that are used either for calorific value or for checking the heat generated by a system. Now this thermal differential thermal analyzer, these are the equipments that are used to assess behavior of a material when it is heated. This is useful in case of thermal decomposition of chemicals. When we are storing or heating chemicals inside a reactor or a storage tank, we must know at what temperature and at what time the material will decompose. This can be assessed through this technique of differential thermal analysis. In this technique, a reference material is placed with a sample inside a furnace and it is heated by means of a thermocouple. Now we know that the reference will be linearly rising in temperature and the sample should follow unless there is a thermal event in the sample. If you can see the graph, this is the red line indicates the sample temperature, whereas the blue line indicates the reference temperature. So when the sample and reference are heated inside a furnace, there is a linearity in terms of rise in temperature in the reference sample. Whereas in the material that we want to assess, what we are calling it as a sample, you can see some jerks below and above the reference line. Now, why this is happening? If you can see, the graph is with respect to furnace temperature against the sample temperature. So the furnace temperature was rising linearly, but with that the sample temperature was also rising. But at certain point of time, the sample temperature did not rise even when there was a rise in temperature of reference. So it means that the heat that was being supplied was not used to rise the temperature of sample. So it would be used for changing either the phase of the sample or it is the heat which is used in other endothermic process. Melting is one of the endothermic process in which heat is used to change the phase from solid to liquid. Through this, we can understand at what temperature the endothermic process will start. Similar is the case with the exothermic process. If you can see here, the rate of rise in temperature of the sample suddenly increased over the reference temperature. This increase in temperature is corresponding to the exotherm that has occurred in the sample because of the thermal decomposition. As the sample was present in as a unique one and it was not interacting with any other material, it means it has thermally degraded and liberated this much heat from its core. Now to analyze this further, there is a first order differential of the graph which we can see at the bottom. So if you can see here, the dt by dt, the delta t per unit time or per unit temperature is plotted in this graph. So you can see that the delta t, which was linear, suddenly dropped. So it indicates that even when there was heating, there was no or low change in temperature, less change in temperature. This is attributed to an endothermic reaction. And when there is a rise in delta T per unit rise in temperature, which means there is additional heat apart from the heat supplied by the furnace. This is because of an exothermic event. So from this graph, we can find out that okay, exothermic event has starts from this particular temperature, and we should not heat this particular material up to this